Good morning. Here we are once again. This is the Physics 105B video lecture 1 for fall semester 2020. I'm going to make this one pretty short just to go through the syllabus and talk about what's going to happen this semester, and I'll try to start a little calculation of something. So I have the syllabus in front of me. I emailed it to everybody. And as we had last semester, I have a YouTube channel, Carl Rundy, with a Physics 105B playlist, and I'm going to populate the entire set of playlists this morning. It says here also, homework assignments are announced in the videos. So pretty much everything's going to be announced in the videos, which is the way we did it last semester. We'll still have the email office hours, and later on we'll probably do some Canvas and Zoom features as well. But for now, it's very simple. It is the YouTube channel and those videos, 3 videos per week, and then the email office hours and the homework and lecture notes. So what's new this time, I'm going through past the course material, is under the homework. I did this last semester in my 2A class. It was so successful that I'm requiring it of all my classes. Namely, I want pictures of your handwritten notes sent to me on a weekly basis. So you work on your notes, you make them really nice, leave a lot of space, everything we talked about last semester. And then Fridays, you take a picture of what you have. You can spread them out on a table. Just make sure I can see that they're real notes, and send them in by email. And that's a substantial part of the grade. It's one of the best things I can do for you. Normally, we're professionals, right, upper division physicists, and we don't have that kind of control, but this will get you something very worthwhile. So you take notes as good as you can work on them, leave a lot of space, and then you send me pictures of the handwritten lecture notes every Friday. It says right here, by Friday evening, no later than 6 o'clock. So you just want to keep up. If you send things more often than Friday, I'm not going to refuse them. Okay, so you can do that too. So what do we have here? Important note, always open a new message. So you open a new message, and that's to my email address, CSU Fresno.edu, okay? And then for your subject, this is going to help me in my bookkeeping. For your subject, then you can call it physics. Actually, that's what I wanted to say. I want your name. So your name, comma, physics 105B, homework / notes. You can send them separately if you want. You can send the notes, and then the homework, of course, the way we did last semester. You want to get a good app that converts pictures to PDFs, so I get something very legible. I can read a picture, but I can't print it out very well, okay? So you have to do a PDF conversion in order to get stuff to print out. Yeah, so that's the main new topic here that I wanted to announce today, just to get the ball rolling. I want pictures of your handwritten lecture notes once a week. The more the better. You can always work on your notes. Okay, so if you're not getting a certain problem, just go to your notes and work on those and repeat all my calculations, make sure you understand them, and the learning will be immense. Okay, good. Other than that, we have a standard examination schedule, and we'll work that out when we get there. Okay, so I always keep this syllabus pretty minimalist. Now the course material, Lagrangian, Hamiltonian, mechanics, gravity, rigid bodies, fluid mechanics. We have more than enough to learn about. We had a good end point last semester because we made it through scattering, differential scattering cross sections. We still have some momentum to talk about and some collision material. Okay, but let me also get us something new so you actually have some notes to get started on. So what we're going to start out with this semester is Lagrangian mechanics. Okay, Lagrangian mechanics, and then we'll learn about Hamiltonian mechanics, possibly at a later part of the semester. But Lagrangian mechanics can be expressed in terms of what's called a variational principle, based on a variational principle which I'll state later. And the variational principle is based on, how about this, something called the variational calculus. So that's our topic fresh topic, the variational calculus. This was developed by Euler primarily, big name. So it goes back to the real formalization of Newtonian mechanics. You had Euler, you had Lagrange, the great mathematicians and physicists. Okay, so what I want to do is give you a little introduction, really just maybe another 5 minutes, to the variational calculus. That's something you can sink your teeth into. And so I'm going to state some questions. You know, this is a sort of a maximum minimum type of problem, optimization problem, except we're not given a function, we have to find a function. Maybe the one that kicked the whole thing off, supposedly, is the brachistochrone problem. Okay, I'll write that in a moment. Here's a nice sketch for you. Here we have an XY axis. And what we're going to do is imagine a curve. Will give us a point A and a point B. Imagine a wire and we have a frictionless bead on the wire. What would be the shape of the curve that minimizes the time? So that would give us the fastest descent, the shortest time of descent to get from A to B on this wire. We can bend it in any shape we want to bend it. I think it's clear. Let me do another color here. Turns out I've actually chosen the curve that is pretty close to the correct answer, but we don't know its name yet. But what I want to point out is, if we had a wire that came in this direction and then dropped down, we could make the time arbitrarily slow, or arbitrarily long. Okay, so the bead slides very, very slowly here and then finally drops down to B. Okay. On the other hand, so there's one. We'll call this one 2. On the other hand, we could do some kind of wacky thing where we go out here and then come in this way. And that's also clearly a longer time. It's going to be a slower time because you're even going backwards a bit, you're dipping down, and you're coming uphill. Okay. So what it shows is the time. Okay, so let's call this the curve of least time. That's our question. What's the curve of least time? And we can see that seems as though there could be a minimum there. Okay. Because this one takes much longer, this one takes much longer. Is there really just a minimum somewhere, a minimum curve? So that's the question. And it has the interesting name of brachistochrone. spelling it right. You guys can look it up. Okay, the curve of least time. So how would we go about discovering what that curve is? Well, we would invent the variational calculus. Okay. But first we would have to formulate the time for a frictionless curve right here, and I'll show you how we go about that. And that'll give us a good thing to talk about here. Okay, so we want the curve of least time. I've explained what we mean by that. Okay. And let's take a look at an infinitesimal time, dt. Well, good thing we're physicists. We could say that's dl divided by v, right? Distance equals rate times time if you cross multiply. Okay. So there's our time, and now we have a curve in the plane, so we should be able to express that. I think we did length elements last semester. If not, yeah, we did, but let's remind ourselves, if we have a y equals y of x, then that dl is 1 plus dy dx squared dx. Okay, there's our length element. And what about the v? So let's do some little numbering here. What about the speed? Well, we have energy conservation. It's a frictionless bead, right? It's a frictionless curve. So we have 1/2 mv squared plus mg y sub 1, 1/2 mv2 squared plus mg y sub 2. Okay, so where are we going to start? Let's release from rest, and then we'll have mg y1 minus y2, 1/2 mv2 squared. v2 is the speed down at any point. So v is equal to 2g y1 minus y2. And y sub 1 is the initial position, y sub 2 is 0. So there's v, and we can plug that in, and we have root 2g y, I'll call it y sub 0 minus y. Yep, so there's the speed. And let's now write down what we have found. This was a little infinitesimal of time. So the time is going to be an integral root 1 plus dy dx squared dx divided by 2g y sub 0 minus y square root. So part way there. And like I said, this is really the classic one that I think these Eulers and Bernoullis were sending back and forth to each other. You know, back in the old days, they used to write down a problem on a letter and send it out in the world, and then the smart guys would have to do some work on it. So here we are. Make sure we have our signs right. Y sub 0 is greater than y, so we're fine there. It's going downhill. So y is equal to y of x, and we could say we've got y prime is equal to dy dx. So what we have here is an interesting problem, and you know, we could prime these x's the way we've often done, and then we'd have x up there. So now we have an interesting problem. This is an unknown function, but this does represent the time it takes to slide down our curve here. And we have to come up with a way to discover what that unknown function is. Okay, so that's a very interesting problem. I'm going to leave that there. So I've set it up. I haven't written down that many words, but you guys, in preparing your notes, you can always stop and take the, you know, write down the notes and put in some more commentary. Okay. Let's see. So there's our question. What's the curve of least time? We'll have x. And we did this construction here. Okay, so I will put one more thing here. Find the unknown function y of x. Okay, so in closing for today, this is just a short lecture, get things going. I'm just going to remind you, I will be trying, my intention is to post Monday, Wednesday, Friday, and just have those lectures available to you by what would be the class time, 9 o'clock. Okay. So those 3 lectures per week, the homework problems will be put in the body of the lecture, and we'll do that the way we did last semester. But a homework assignment that you can always be working on is preparing your notes, writing out your notes, working on your notes, and then those you can always send me by Friday evening at 6 o'clock. In fact, just send what you have. Okay, hopefully you have everything. On the other hand, the homework assignments, the actual homework problems, we'll do separately, and we'll talk about the due dates as I write them up on the board. Okay. But the lecture notes are always due Friday afternoon, whatever you have, and they should be complete up to the Friday lecture, because I'm posting it in the morning, and then you have till 6 o'clock to write them down and make them nice. Okay, that's it for today. Wish everybody luck in all of their classes. We're going to make it a great semester. For us as physicists, there's no lost time at all, because this is the way we work anyway. Okay. Good. So see you next time.